Hello, my name is James-Antaki. I'm the director of the Artificial Organs Lab at Carnegie Mellon University. I'm here today to tell you about a $300,000 grant we received through NIH and through the stimulus program to support development of treatments for malaria. Malaria, whether you know it or not, is one of the most pandemic diseases in the world. Over 300 million people have malaria in the world. Only 1,000 of them are in the United States, so it's obviously not a huge U.S. domestic issue, but in the sub-Saharan desert, over 1 million people die per year, and most of them are children and pregnant women. Well, my colleague discovered a method of removing the parasite from the blood of patients that have malaria by using magnetism. It so happens that the research in our lab relates to the use of magnets for a different purpose, and also to the study of flow of blood cells. So it was a perfect synergy between this problem and the research that we had already been doing in our lab. And we're now beginning to develop a device that could be used to filter the blood of these patients and save their lives. The funding is going to be used to support my colleague, who is a physicist, just received his MBA from Tepper School of Business here at Carnegie Mellon, and would otherwise be out of work. I mean, he would be flipping burgers or just unemployed. And now we're able to support this talented individual for at least 2 years, get the project up and running, and because of his entrepreneurial interests, he's going to begin developing a company that hopefully can commercialize this therapy, export it to the third world, and hopefully contribute our share to the balance of trade. We have basically 2 people working on the project right now. At our current pace, we might have a prototype that we could potentially test in humans in 2 years at the end of this program. And we're likely to start our trials in South Africa because yet another serendipitous coincidence is that a colleague of mine is developing an artificial blood substitute for South Africa. And we might be collaborating with him to begin our clinical trials. Our lab for the past 5 years has been working on a miniature blood pump to treat children with heart diseases. The unique property of our blood pump is that it has a magnetic levitation system, just like a magnetic levitation train. It's a rotary pump, which means it has a propeller, kind of like a jet engine or a vacuum cleaner. It spins at 10,000 RPM, and the research challenges has to do with maintaining a rotating impeller at that speed without wearing out and without damaging blood cells. So the advanced magnetic research we're doing for the levitation combined with the advanced blood research we're doing for blood trauma is serendipitous with this project for magnetic removal of malaria from blood.